Okay, for question 11, it talks about decide if the variables are discrete or continuous. Remember, discrete is something you can count, and continuous happens over a range. So the amount of soda that is in your cup when it's served to you, this will be continuous. Now, why would amount of soda be continuous? Can't you just measure that? Well, think about it. If I put up a cup of soda and I have a full, and then you have a cup of soda and you fill it up, is it really going to be exactly the same? Or is there a range of answers? So any sort of measurement like weight, how much soda in a cup, that would be continuous. There's a range of answers, not going to be exactly the same. How much time it takes when you leave your house to arrive at work? Again, that's going to be continuous. Now you may say, hey, it always takes me 20 minutes. Does it exactly take you 20 minutes every single day, or maybe one day 20, one day 25? There's a range of answers. How many people in the class? That would be discrete. That is something we can actual count. 1, 2, 3, 4, 5, 6, 7, all the way up to 28 people. That's something we can count. The blood pressure when you get it checked, that would be, again, continuous. Why is it continuous? Because with blood pressure, you may check it, wait a little bit, check it again, wait a little bit, check again. It can range. There's a range of answers. And the number of donuts at your local donut shop, that's something you can actually go and count. How many donuts do they have at that moment? That would be discrete. For 12, we're going to look at creating a probability distribution graph. So I got people's favorite color. 100 people said blue, 90 people said black, 75 said green, 60 said red. Step 1 is to add all those up, and if you add all of those up, you will get 325. Then, to find the probability, you're going to take 100 people out of 325, 90 people out of 325, 75 people out of 325, and 60 people out of 325. Now I'm going to go to the calculator because we're going to go from fraction to decimal to percent. I'm going to go 2 decimal places, but we want to be careful going from fraction to decimal to percent. So if I type in 100 divided by 325, that will give me 0.307692. We're going to go 2 decimal places. So we'll say, actually, let's go 4 decimal places to practice that. So it would be 3076, and then the 9 makes the 6 go up to 7. So that would be 0.3077, 0.3077. And then to go to a percent, we move it over 2, so that would be 30.77%. Then the next one, let's say 90 divided by 325. So we're going to do 90 divided by 325. That gives us 0.2769. Then the 5th one is 2, so the 9 stays alone. So that'd be 0.2769. 0.2769, which would be 27.69%. Then we have 75 divided by 25. So we'll put that in the calculator. 75 divided by 325. That gives us 0.23076. So the 6 makes the 7 go up. So that'd be 2308, 0.2308, which would be 23.08%. Then we have 60 divided by 325. 60 divided by 325. That would be 0.1846. Again, the 6 is next to the 1. 1 means it stays the same. It has to be 5 or larger to round up. So it's 0.1846. 0.1846, which would be 18.46%. Now, the decimal should add up to 1, about, and the percent should round up to 100, about, because, again, we rounded. But that means that's everybody's favorite color. Now, to make the probability distribution graph, we're going to put the colors on the x-axis, and we're going to put the probability on the y-axis. So the colors we have are blue, black, green, and red. And the highest is 0.31. So I'm going to start at 0. I'm going to count by 0.1s, 0.2, 0.3, go up to 0.4. And blue has 0.3077. So I'm going to put a line up to that. Black has 0.27 or about 0.28, so I'm going to go up to that. Green has 0.23, I'm going to go out to about 0.23. And red is 0.18, so I'm going to go up to about 0.18. And you can see, looking at our distribution graph, that the most popular color is blue, followed by black, followed by green, followed by red.